Good day, everyone. Today, Daniela and I are diving into a fascinating debate. Is mathematics invented or discovered? This question challenges how we think about math's role in the universe.
This is a question that has intrigued mathematicians, philosophers, and scientists for centuries. Through this presentation, we will explore both perspectives, introduce key thinkers, and examine how math help us understand the universe. We will also consider a combined view that bridges these ideas and leaves us with even more questions to ponder.
Mathematics is all around us. It presents in the spirals of galaxies, the patterns of flowers, the geometry of buildings, and even the algorithms that run your smartphone. It plays a critical role in science, engineering, medicine, economics, and art. But the big question is, did humans invent math as a tool to understand the world, or did math exist independently as a natural truth waiting to be discovered?
Today, we will explore three perspectives. First, the math as discovery. Second, math as an invention, and a combined view that blends both ideas. Throughout this presentation, we will look at two views, math as a discovery and math as an invention. As we go through, we will highlight key examples and thinkers that support each view. By the end of this topic, we will see how these two ideas might come together. Let's begin by discussing the idea that math is discovered. This perspective argues that mathematical truths exist independently of us. They are not created but instead found through observation and logical exploration. For example, consider the Fibonacci sequence. This mathematical pattern which starts with 0, 1, and continues with the sum of the previous two numbers appears everywhere in nature. From the arrangement of leaves to the spirals of shells and galaxies, this suggests that math is not something we invented, but something inherent in nature, waiting for us to discover it.
Another example of math as a discovery is pi. Pi is the ratio of a circle's circumference to its diameter, and it has been found in all circles, regardless of size. This constant is not something humans created. It's a fact of geometry that we have only uncovered through observation.
The Pythagorean theorem is another example. It states that the square of the hypotenuse in a right triangle equals the sum of the squares of the other two sides. This was discovered independently by civilizations like the Greeks and Babylonians, showing that mathematical truths are universal and not found by time or culture. These discoveries suggest that math exists as a set of objective truths, regardless of whether or not we're around to observe them.
Supporters of the discovery perspective are called Platonists. They argue that mathematical truths exist independently of human thought, much like the laws of nature. These truths are not created, they are simply uncovered by humans. Key figures who supported this view include Roger Penrose, who believed math exists in an abstract eternal realm like a hidden treasure waiting to be uncovered. He argued that we as humans merely discover this mathematical truth through exploration. And also Kurt Gödel, whose incompleteness theorem showed that there are certain truths in mathematics that exist but cannot be proven through logical means. This reinforces the idea that math is a discovery. It's there, even if we can always prove it. Even pure mathematicians like Godfrey Harold Hardy, who work on number theory, believe that math is a field of timeless, universal truths that we uncover, not create. Yet his discoveries later contributed to fields like cryptography, showing how even abstract truths can connect to reality. This makes a strong case that math is a discovery of universal principles. Now let's explore the argument that math is invented. This view suggests that math is a product of human creativity designed to help us understand the world.
Take the concept of zero. This was an invention. There was no zero in nature. Early humans created zero to represent the absence of things, and it helped make the concept of numbers more robust. Similarly, imaginary numbers were invented by mathematicians to solve equations that didn't have real solution. These were abstract creations to fill gaps in understanding.
Another excellent example is calculus. Isaac Newton and Gottfried Leibniz invented calculus to understand motion and change. Without calculus, we would not have been able to describe the movement of planets, build bridges, or understand the behavior of particles. Calculus wasn't discovered in nature. It was a creation made to fit the problems at hand.
Supporters of this perspective are known as formalists. They believe that math is a human creation, developed to solve problems and make sense of the world. Unlike Platonists, formalists argue that math doesn't exist independently of humans. It's a tool we made up to describe patterns in nature and to solve problems we encounter. Key figures who supported the idea of math as an invention include, first, Albert Einstein, who viewed math as a tool created by humans to interpret and predict the universe. He believed that math doesn't exist independently, but is tailored to explain the phenomena we observe. Second, Nicolas Bourbaki, a group of formalist mathematicians emphasized that math is a system of symbols and rules that humans invented to organize the world. According to them, math is a logical structure created by human minds, not a force of nature. And lastly, Isaac Newton, who invented calculus as a system to understand the world, showing how math can be crafted to solve specific challenges.
Different cultures also develop unique mathematical systems. For example, the Mayans used a base 20 system for their math, while most modern societies use a base 10 system. This shows that math evolves based on human experience and needs, supporting the idea that it is invented rather than discovered.
Even today, new mathematical ideas are being invented. The rise of machine learning and artificial intelligence has led to the development of entirely new branches of mathematics that were not needed before. This ongoing development of math as a tool for solving new problems supports the idea that math is an invention.
So, where does this leave us? If math is discovered, why does it align so perfectly with nature? For example, patterns like the Fibonacci sequence and constants like pi repeatedly appear in the world around us, from the shapes of plants to the formation of galaxies. This strongly suggests that math is a universal language inherent to nature.
But if math is invented, how we do explains its effectiveness? For instance, knot theory was invented as an abstract concept, but it became critical for understanding subatomic particles and other complex systems in physics. Similarly, imaginary numbers, once dismissed as impractical, are now essentials in fields like electrical engineering and quantum mechanics. This shows how human inventions often reveal deep truths about the universe.
This raises a big question. Does math work so well because it's universal or because we've designed it to fit our understanding of the world? For example, imagine a jellyfish which experiences the world in a completely different way, creating its own version of mathematics. Their mathematical systems might look very different because their perception of reality is different from ours.
Even our mathematical systems are shaped by our human experience, we focus on counting distinct objects because that's what we've evolved to recognize. But if we experience the world differently, say if we had a continuous flowing perception like jellyfish, would we invent math in the same way? It is a question worth thinking about. Many thinkers today believe that math is both invented and discovered. We invent tools like numbers and equations to help us solve problems, but those tools often uncover deeper truths about the universe. For examples, Riemann's geometry was invented to study abstract spaces, but it later became essential for Einstein's theory of relativity. Similarly, knot theory, which began as an abstract invention, turned out to be fundamental in particle physics.
This combined view shows that math is a creative invention that helps us make sense of the world. But once we've invented these concepts, we often discover how they relate to the fundamental truths of nature. It's a perfect blend of human imagination and universal patterns.
It also raises a profound question. Are we truly discovering universal truths about the universe, or are we simply creating our ways to interpret our experiences?
Math helps us understand universal laws, like symmetry and locality. Symmetry means that the laws of nature don't change depending on where or when we observe them. For example, the force of gravity is the same whether you're on Earth or on the moon.
Locality means that objects are only influenced by their immediate surroundings. This principle allows us to build models of everything from quantum particles to the entire universe. But why do such universal laws exist? Even though we understand these principles, the question remains, why do such universal laws exist in the first place? Why does math seem to fit so perfectly with the structure of reality? Is it because math is a fundamental part of the universe? Or is it because we've created models that match the patterns we observe?
That's the mystery we are still trying to solve. It seems that the universe operates on principles that we can describe mathematically, but we don't fully understand why these laws exist. Do these universal laws exist because math is a fundamental part of nature, or do we simply describe them through the mathematical lens we've invented?
Mathematics connects human creativity with the natural world. It helps us uncover mysteries about the universe and interpret them through our own lens. Yet, one question remains, why does math work so perfectly? Is it the language of the universe? Or is it just how we choose to interpret the world?
In the end, math is an extraordinary blend of invention and discovery. We create systems to solve problems, but those systems often reveal universal truths that were already embedded in the world around us.
Mathematics connects human creativity with the natural world. It helps us uncover mysteries about the universe and interpret them through our own lens. Yet, one question remains, why does math work so perfectly? Is it the language of the universe? Or is it just how we choose to interpret the world?
So that's the end of our topic on whether math is invented or discovered. To give you a deeper understanding, we prepared a video with more information for you.
Would mathematics exist if people didn't? Since ancient times, mankind has hotly debated whether mathematics was discovered or invented. Did we create mathematical concepts to help us understand the universe around us? Or is math the native language of the universe itself, existing whether we find its truths or not? Are numbers, polygons, and equations truly real, or merely ethereal representations of some theoretical ideal? The independent reality of math has some ancient advocates. The Pythagoreans of 5th century Greece believed numbers were both living entities and universal principles. They called the number 1 the monad, the generator of all other numbers and source of all creation. Numbers were active agents in nature. Plato argued mathematical concepts were concrete and as real as the universe itself, regardless of our knowledge of them. Euclid, the father of geometry, believed nature itself was the physical manifestation of mathematical laws. Others argue that while numbers may or may not exist physically, mathematical statements definitely don't. Their truth values are based on rules that humans created. Mathematics is thus an invented logic exercise, with no existence outside mankind's conscious thought, a language of abstract relationships based on patterns discerned by brains, built to use those patterns to invent useful but artificial order from chaos. One proponent of this sort of idea was Leopold Kronecker, a professor of mathematics in 19th century Germany. His belief is summed up in his famous statement, "God created the natural numbers. All else is the work of man." During mathematician David Hilbert's lifetime, there was a push to establish mathematics as a logical construct. Hilbert attempted to axiomatize all of mathematics, as Euclid had done with geometry. He and others who attempted this saw mathematics as a deeply philosophical game, but a game nonetheless. Henri Poincaré, one of the fathers of non-Euclidean geometry, believed that the existence of non-Euclidean geometry, dealing with the non-flat surfaces of hyperbolic and elliptical curvatures, proved that Euclidean geometry, the long-standing geometry of flat surfaces, was not a universal truth, but rather one outcome of using one particular set of game rules. But in 1960, Nobel Physics laureate Eugene Wigner coined the phrase the unreasonable effectiveness of mathematics, pushing strongly for the idea that mathematics is real and discovered by people. Wigner pointed out that many purely mathematical theories, developed in a vacuum, often with no view towards describing any physical phenomena, have proven decades or even centuries later to be the framework necessary to explain how the universe has been working all along. For instance, the number theory of British mathematician Godfrey Hardy, who had boasted that none of his work would ever be found useful in describing any phenomena in the real world, helped establish cryptography. Another piece of his purely theoretical work became known as the Hardy-Weinberg law in genetics and won a Nobel Prize. And Fibonacci stumbled upon his famous sequence while looking at the growth of an idealized rabbit population. Mankind later found the sequence everywhere in nature, from sunflower seeds and flower petal arrangements to the structure of a pineapple, even the branching of bronchi in the lungs. Or there's the non-Euclidean work of Bernhard Riemann in the 1850s, which Einstein used in the model for general relativity a century later. Here's an even bigger jump. Mathematical knot theory, first developed around 1771 to describe the geometry of position, was used in the late 20th century to explain how DNA unravels itself during the replication process. It may even provide key explanations for string theory. Some of the most influential mathematicians and scientists of all of human history have chimed in on the issue as well, often in surprising ways. So, is mathematics an invention or a discovery? Artificial construct or universal truth? Human product or natural, possibly divine creation? These questions are so deep, the debate often becomes spiritual in nature. The answer might depend on the specific concept being looked at, but it can all feel like a distorted Zen koan. If there's a number of trees in a forest, but no one's there to count them, does that number exist?
We hope you've enjoyed this exploration of mathematics and its role in understanding the world. Thank you for your attention, and we look forward to your thoughts and questions on this intriguing topic.